Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming to you from the Mozaic Works studios, and what I have for you today is an overview of an InfoQ article called A Simple Framework for Architectural Decisions. It talks about a few techniques that I agree are very useful, and things that I've noticed were very well received by wannabe architects who come to our courses, or actual architects who want to improve the way they work. So I think this will be very, very interesting. Before I go on, I like to remind you that we love comments. Please leave us a comment. And also, I would like to thank you all. We have passed 500 subscribers. So good job, everyone. Thank you so much for your participation in this channel, and we'll just keep on going with the videos. And as usual, let us know in the comments if there's anything that you find interesting that we should talk about. If there's anyone that we should talk to, please let us know. With this being said, another programming notice is we are actually gonna move office next week, and this means that we will have a video, but it will be probably recorded much earlier than usual, and hopefully we will have in the next week, since we are moving all the studio equipment and everything, I hope everything will work just fine. But in case it doesn't, I will just record something extra for you to have in 2 weeks' time. All right, so let's get into it. This is an article from InfoQ called A Simple Framework for Architectural Decision. It's written by, okay, this will be a name that's difficult to pronounce, Grigory Gonchar, I think. I hope I'm not butchering the name. Reviewed by Thomas Betts. Thomas Betts we've gone through a number of articles reviewed by Thomas, and all quite interesting. And Grigory Gonchar is a VP of Engineering at Heycar. So, very interesting. All right, what are they talking about? Let's see. They're talking about an internal technology radar, which is something that's very useful, technology standards, and architectural decision records. These are three things that I have seen again and again that are very helpful for architectural decisions, because you need to have some kind of guidance, and particularly when you are working with a lot of self-organizing cross-functional teams, like in an agile type of organization. With those kinds of teams, they will make a lot of their own decisions related to design, and some of them even spill into architecture. And it's important, therefore, to define what are the constraints within which these teams can make decisions. And there's a term in the complex adaptive systems style of thinking, which is about enabling constraints. What you want to do is to set up some constraints that allow teams to make decisions, but also enable them to move into the right direction as fast as possible. One example here, if you just go to a team and say, okay, do whatever you want, and you don't give them any project, any language, any technology, anything, just figure out something to do and then do it. What will probably happen, I mean, in some cases, they will manage to figure it out and do something that's useful. But in other cases, and I would say probably most cases, there will be a lot of negotiation, and they will not end up with something to do that is actually useful. So things like what we are trying to build, why we are trying to build it, what problems we are trying to solve, what technologies are we allowed to use, and some degree of security that is needed, some degree of performance that is needed, and so on. These are very important things to have, and these are enabling constraints. They are constraints that allow the teams to make decisions faster and actually go into a good direction. And so let's go into the examples here. Simple framework for architectural decisions. Software engineers must make architectural decisions to proceed with the development. Can we use Python instead of Java for our new microservice? Can we use another bundler when developing our new front-end library? Should I agree on the repository structure with my manager or other teams? Should I use snake case or camel case when I'm designing the REST API? The company needs to establish a clear framework for making those decisions, who needs to be involved, and where to find information about already done decisions. It's essential to make such a framework right, as it will define how much freedom and autonomy different teams have. They should align with the business needs and the company culture you are trying to build at a given stage. Absolutely. So this is what I was talking about. These are all examples of enabling constraints. Particularly, I love this one. Should I use snake case or camel case when I'm designing the REST API? It doesn't matter. Both are good. So instead of having a conversation about those, just decide on one and have it a standard in your organization, and that's it. And you move on to discuss much more important and interesting issues. But it's correct, and this has been a long issue in software development, that decisions, it's hard to remember the decisions that you've made. There were some attempts in various places to remember these decisions. At some point there was, I think in XP, in Extreme Programming, there was this notion of a team journal, where teams could write down their decisions and look at the decisions and say, oh, so this is what why we made a certain decision in the past. Problem with that is, often when you make a decision, you don't know the influence it will have. So some decisions seem small but will be very influential. Some others don't seem that seem influential and don't have that much influence, and others, actually fit in their correct categories. So this is a problem, and the newest way of doing that is architectural decision records, which store decisions related to architecture, and we'll see this in a moment because I've noticed they are talking about it in this article. But architectural decision records also face kind of the same problem. How do we know which decision is useful, is influential, which one is not? So there will be some decision that will not be in architectural decision records but will be influential, and you want to remember why those happen. This is why also we are dealing with something called tacit knowledge, the knowledge that is built into the teams. If you have a project if you're working on a code base that is 10, 15 years old, and you still have some of the people who have been working from the beginning, you can ask them, why did you make that decision? And they will tell the story. But it's mostly about the stories and some people who remember. In time, this knowledge tends to go down and tends to dilute. Another thing that people have tried was to have kind of a chronicle, so a person responsible for gathering the stories of teams. And they tried it for a while in a bunch of large companies, but then I haven't heard a lot about that anymore. So it's very interesting to see how we will solve this at some point. In a way, it's a problem of folklore, because basically what we are having is we're having a micro society that builds its own folklore in time. And that's how software development is. I know it doesn't sound that great, but this is where we are. And it's good to know where we are if you want to improve things. All right. So, in this article, I like to share key building blocks with such a framework for making architectural decisions could have based on my recent work experience across organizations of different scales. These building blocks include your own tech radar, technology standards, architectural decision records. All right, so technology radar, in case you don't know, this is something that was created by ThoughtWorks. It looks like this. They publish a new version every once in a while. I think we reviewed the last technology radar in a previous video, so I won't go into more details. But basically what it's about is it shows the things that you should adopt, hold, assess, and try. And they don't have here the 4 different quadrants. Let me show you. You have 4 quadrants: techniques, tools, languages and frameworks, and platforms. So for example, you'd have something like Delta Lake, which is a platform, open source storage layer, blah, blah, blah. And so it's a platform, and ThoughtWorks recommends adoption, which is the strongest recommendation. But of course, this is the opinion of ThoughtWorks, and ThoughtWorks' opinion might not hold for every organization. So actually what you can do is to build your own radar, and they offer a tool for building your own radar. ThoughtWorks offers this tool. You can start building your own radar, and this is something that I advise architects and technical leaders to do, because this gives a very good, once again, it's about enabling constraints. Maybe you have certain people in your teams who are big fans of Haskell, but you are a Java-based organization. And then you might say, okay, let's try to adopt Haskell or to try it in certain parts of the organization. Or you might decide and say, look, it makes no sense to us, so no, we are not going to do that. And instead, maybe we'll try Clojure or something else along functional programming that fits in the Java ecosystem. So, and here it's a description on how they use the TAKR, the different stages. At first, new technology is in assess. It's actively researched and evaluated. The assessment stage usually ends with a proof of concept and an extensive list of pros and cons of the technology usage in our environment. This is very important. It's not about how this fits any company. It's about how this fits your own environment, taking into account what your colleagues know, taking into account what the architects know, taking into account the kind of products you're building, and so on. We then discuss outcomes with the respective internal community of practice or teams that may interact with it. If the list of arguments and proof of concept implementation is convincing, the next step is a controlled trial period. During the trial period, the technology is pioneered in production for a single use case only. That makes a lot of sense. Do a small experiment, see how it works out in production. If that step is successful, we declare the technology adopted and give any team a green light for further usage. So this is when you say, okay, anyone can now use this technology. Maybe you have you need to undergo some training. This is where you can get the training and so on. If the new technology is superseding the previously used one, it might be needed to signal that. That's precisely how we use the hold status for the technologies we no longer aim to use and have a replacement strategy. Yeah, that makes a lot of sense. So this gives you a good landscape of technology, and you know as a developer where to go, right? What to try, what to look at. That's really good. So I highly recommend tech radars for any organization that has a lot of teams. Like probably if you have more than 10 teams, it's already the case to look at that. It's a very useful thing to try. Then the second recommendation, introducing internal technology standards. Let's see what they mean by that. Establishing consistent practices for things that apply across different parts of the system can be helpful. For example, you might want to ensure all logging is done in the same format and with the same information included. Yeah, this is, I understand. This is what I usually call policies, like an error management and logging policy. These should be clearly defined for multiple products and customized for your particular product. And same for REST APIs, kind of have a policy of conventions, things that everybody should follow. And then it's about standards for the different technologies. So technology standards define the rules for selecting and using technologies within your company. They ensure consistency, reduce the risk of adopting new technology in a suboptimal way, and drive consistency across the organization. Yeah. Who should be in charge of the standards? Technology standards should be created and maintained by a cross-functional team of experts in relevant fields, and so on. Yeah, I think this makes a lot of sense. And here, I think the technical leadership plays an important role here, which is why I believe that a CTO and the architect should be the ones driving this effort. I've often seen organizations that use a kind of a separate quality department for that, and it's not the greatest idea. It's best if the standards come from people who are actually using those technologies in production. You can start from the general recommendations. So in a simple case, let's say you're doing Java REST APIs. You take recommendations about Java, you take recommendations about REST APIs, you put them together and say, okay, these are the things that we need to do, the guidelines that we need to do. It's also important for these things to be fairly short, because if for every project you need to read like 50 pages or 100 pages of guidelines, it's going to be hard. So instead, try to have them fairly short, like 2 pages per policy, the most important parts. And then, okay, you might have something for logging, something for how you write code in Java, something for security, and something for REST APIs. And this is manageable. This is something that you can do. But also, in addition to this, you'd also need to have some static code analysis tools put in place with the right rules selected so that they help you sustain this process. It's also very important for every rule to have an argument on why it's important, and examples, so that people understand, developers understand why that is needed. Based on internal standards, you can create quality gates such as checking for test coverage, integrity call interchecking for naming conventions or formatting, or fitness function verifying your architecture or repository structures. Yeah. Don't simply tell people when they've done something wrong, make it easy to do the right thing by default. This is the most important part. Just make things easy. Have templates that help you, like a project template that you can use to create a new Java REST API and that has everything you need in it. All kinds of things. I like that they are mentioning fitness functions. Fitness functions are, I think, underused. I think we can make a lot of things with fitness functions. We've done some videos related to that, so yeah, check that out. So yeah, technical standards, absolutely a good idea. Third technique are adopting architecture decision records practice. And I've just talked in the beginning about ADRs. I think they are very important. They have some disadvantages. The fact that some of the decisions might not be captured, but it's still great to have some decisions captured that are influential and that you might go back and look at and say, oh, why did we decide on that? This is very good. The third building block is creating ADRs, so lightweight RFCs. I guess that would work. I've never enjoyed the RFC format. I find it quite difficult to read and understand, but if you come from a very standardized world and are used with RFCs, then absolutely, and that's a proven format, so why not use it? ADRs are a way of documenting architectural decisions and their reasoning. They provide a historical record of important decisions and help teams understand why a particular approach was chosen. An ADR should be created by the team responsible for making the architectural decision. They should include information such as the problem being solved, the alternatives considered, the decision made, and the reasoning behind it. Very important. All of these are important. They are immutable documents, also very important. When a given decision is revisited, it results in a new document being created. You need to have a chain of decisions. Okay, ADR practice is becoming increasingly popular, so major cloud providers such as AWS and GCP added it to their respective documentation. Cool. Let's see. I didn't know that. All right. So this is from... Oh, this is actually quite recent, from March 2022. So, okay. This is a very good sign. I'm a big fan of ADRs. I think more organizations should adopt it, and seeing the large providers doing that, it's a good sign. While technology radar and standards are supposed to give guidance and expected boundaries to the technical decisions, ADRs capture the reasoning and document the particular one-time decisions, reasons for creating a new service or package, introducing new technology, or any other major architecture change. ADRs are typically stored in a central repository and documentation tool and are accessible to all relevant teams. There are actually simple tools that help you store ADRs in a Git repository, which means that you can either store them along with the source code, particularly if you are using also architectural diagrams created by code, that is a very good idea. You can have them all together, and you can have them either with the source code, or you can have them in a separate package, in a separate repository, where in case you have multiple people who are interested in the ADRs but not necessarily in the source code. So yeah. Like for the first two pillars, the process covering the final say in finalizing ADRs and what decisions are considered major enough to require an ADR would be different for every organization. To avoid duplication, you may use ADRs to agree on particular design choices for building a new major system change, while agreeing on a broader use of languages, tools, and practices using the radar and standards. Having the internal technology radar and standards in place, agreeing on an ADR should be a lean and straightforward exercise, as the most substantial technological choices and principles are already aligned. I absolutely agree with this, and all of these are actually examples of enabling constraints. Technology radar, it gives you just enough guidance to know where not to go and to know what is the direction of the organization, but it also gives you enough freedom to explore, which is great. Standards, kind of the same. I mean, when these standards are done well, you will not feel constrained by them. You will feel that they help you build the right thing and just focus on solving the problems of your particular product. And ADRs, they offer two benefits. One of them is seeing the decisions from the past, in case you ever wonder, or somebody joins your team and they ask, okay, why did we choose to do that? And then you can show them. But also to agree on important decisions between different teams or teams or product organizations or products or whatever you have there. So all of these are very, very useful, and it's not such a big thing to implement them. Of course, I'm talking about large organizations here. In any organization where people cannot all get together and kind of have a good conversation about the techniques and practices and so on. So yeah, absolutely. And their conclusion is, together the technology radar, technology standards, and ADRs form a framework that provides a clear and consistent approach to making architectural decisions, reducing the risk of new technology adoption, and providing a historical record of important decisions. By establishing a framework for architectural decisions, teams can ensure that their technology stack is aligned with their business goals and that their teams have the information and guidance they need to make informed decisions. The degree of freedom your team has and the process to change the radar standards or ADRs will shape your engineering culture. Some organizations aim for radical team autonomy. This would mean each team can make their own decisions. This works great, but you need to follow Conway's law, right? If you want teams to be disconnected and make their own decisions, the architectural elements also need to be disconnected, decoupled. So in this case, probably the best solution is to have services that communicate through events, because that's the most disconnected, the most decoupled way of implementing this. Or microservices, if you want to call them like this. Some organizations aim for radical team autonomy, and some aim for high consistency and alignment, which are more restrictive. And I think there are here some things that make sense to discuss at the higher level, particularly when you have multiple services, multiple products, there's there are some concerns related to security, there are concerns related to performance, to infrastructure costs, and well, for any type of management, you can approach it in two different ways. You can approach it as a completely distributed, which means teams can decide whatever they want. And on the other side, you can pick a very centralized style of management in which you give all the rules and you expect everybody to follow. Typically, even with the organizations preferring a lot of team autonomy, they still need to have certain constraints. And yeah, this is what shapes your culture. So even if you are aiming for team autonomy, you can still facilitate decisions. And I think they are talking about this, pick senior technical leaders or senior engineers, involve them into making decisions and negotiating and making decisions that will apply to multiple teams. That would be a kind of a group exercise rather than something that is imposed from outside. So there are various levels of doing this, but generally radical team autonomy, I've only seen this working in very specific contexts, in organizations like, in parts of Google and in Valve, which both have a similar context in the sense that they decide to have certain products or a part of the organization where teams can organize however they want, and it's basically like a startup culture. They try out various things, and if something catches on, then it becomes a product. And it's basically a number of small bets. Like they are betting on 1,000 different things, and maybe 10 of those will be a big gain. But they can do that because they have a lot of money from the main business, which is more constrained. And this is how these things work. So honestly, radical team autonomy, it exists in some XP organization. But other than that, it's quite rare, and it'd be interesting to see how it works in reality, because at some point there were a lot of stories about how this type of organization will take over the world and so on, and it didn't happen. So it's still very interesting. All right. So this was the article, and I think in conclusion, 3 techniques, very useful, highly recommended. If you work in a large organization, if you are an architect, or if you have architects, go and talk to them and show them this, and this is something that maybe you'd like to try, and we can also help you try these things out and setting things up and facilitating these decisions and so on, because there are a few intricacies in making this work in a way that leads to actual enabling constraints. That's all for me today. Thank you kindly for the view. Please leave us comments. We love comments. We'll always answer them, and we will always answer them as soon as possible. As I said, we will be moving office, so it's likely that the next time, if not next time, the next time you will see us in the new studio. So that will be cool. Can't wait to get there. Can't wait to have more conversations with you. So leave us some comments. Thank you so much for your support and for subscribing to this channel. I hope that we'll take it soon to even more, 1,000 subscribers, who knows. Anyway, thank you kindly for the view, and until next time, remember to think, design, and work smart.